everyone, and welcome back. We're hoping that you've been having a great day so far and that you enjoy the rest of the sessions that you attended. There are some announcements I'd like to make before we go on with the session. First, I'm Arzak. I will be the host for this afternoon in this room. After today's final session, we will be networking at the Space Bar from 5 to 6 p.m. This is a last chance reminder to enter the competition. I think you noted that in your booklets. The arcade closes today at 5 p.m., so make sure to check it out. We have a great event lined up in person on June 4th with Deliveroo. If you are interested, please check it out at datasciencefestival.com to sign up for free. We're going with our next session titled Cooking with Data and How We Built Machine Learning Models to Power Feast. The speaker is a data science leader with a background in physics and deep domain expertise in the publishing industry. Since joining The Guardian in 2019, she has built one of the largest teams within the analytics department. Previously at the BBC, she received a Best Producer award before transitioning to data science in 2015. Her expertise spans in NLP, recommender systems, audience segmentation, and A/B testing. She also teaches AI ethics at LSE's AI Academy for small newsrooms. So please welcome with me Anna Vissens.
Hello, everyone. Thank you so much for inviting me. And I think that the organizers probably strategically put my talk after lunch because otherwise you wouldn't be able to listen to me. You would be too hungry. So I'm going to talk about, indeed, how we build machine learning models for our recipe app, which we call Feast. We launched the app in April 2024, so a little bit more than 1 year ago. And it's a subscription app, so it's a paid-for app. And last time I checked the rating in the Apple Store, I think that it was like 4.8, 4.9, so we are doing pretty well. So The Guardian, many of you probably know, is quite famous for their food content, and we have an amazing lineup of chefs who write for us every day. In our archive, we have more than 30,000 recipes, spanning like back years and years. And when we launched the app, we had curated at this point around 3,000 recipes. Now we have 7,000 curated recipes in the app. And obviously you might ask, well, if you have 30,000, why you don't put like everything in the app, right, straight away? Well, we will talk about that, why we couldn't do that. So that was our journey. It all started before my time, actually, at The Guardian. In 2016, The Guardian decided to look at this amazing content, which we call sometimes evergreen content because, it doesn't expire. And the initiative was called Recipe Easy. We basically asked everyone in the company to volunteer and to curate the output of a very simple pipeline that engineers built at that time. But this pipeline was based on very simple HTML tag rules and regular expressions. And when we started doing that, after a couple of months, we realized that actually it just takes too much time to curate the output of this pipeline, and mostly because we missed data. It wasn't that incorrect data that you can probably have a problem with generative AI, but it was just missing data because some rules didn't capture everything that we needed. So we basically paused at this time. And when I joined The Guardian 3 years later, and I started talking to the newsroom and editors, and they recalled this project, I thought, gosh, this is just such a nice use case for machine learning. But at that point, I was very busy building the team because I started from scratch at The Guardian. There was no data science team at that point, so we didn't have any resources to do this properly. So what we did, I just invited a fellow, a PhD doc in particle physics from UCL to work, for us for 3 months, Zara Grout, and she built the baseline models for us, basically proving the concept that it was possible to do. After that, we played a little bit with the data that we had at that, after this project. We modeled dietary requirements. We looked at how we can model and predict cuisine type. But at the end, in around late 2021, I think, we were at the point when, we just had to do something with this data. And to build a proper product, many of you, if you ever build a product, know that it's not enough to have just a model on your local machine working perfectly. You actually need much, wider resources, engineers, web developers, app developers, if we are talking about the app, UX designers, and you name it. So we didn't have resources like that at that time. So we hit the pause button again. But in 2023, the business started looking at this content again with a very clear objective to monetize this content, because, why not? And we went back, we revived all our models, and I will talk about challenges about that, like forgetting your models for 3 years and coming back to them. But we launched the app in 2024. So you might ask, what's the problem? So indeed, why you cannot just repurpose what you have already on the web, already available online. So there are several problems. First of all, our food articles are usually a collection of recipes. So in one article, we have 2, 3, sometimes even 10 or 15 recipes, if it's a collection, like best Christmas recipes or something like that. But we rarely have just one article and one recipe. So that was challenging, and actually with the first pipeline in 2016, that was the main challenge, because the pipeline couldn't actually identify where the one recipe ends and another starts, even with HTML tags, etc. So and another problem that you might spot here, that some of our chefs like writing recipes in a very prosy way. I don't name people, but some chefs we have to process, twice, basically. So this is a problem. If you want to build an app, you want some sort of, left-hand view, right? And to do that, you have to extract a lot of data and to present it in a different visual way. So the only way to do that is actually have something behind, something like that. So basically, we are talking about unstructured data versus structured data. So this is unstructured data. The table is structured data. So obviously, you have, in this particular instance, you have a recipe ID, very important for the table. Then you have ingredients, but it's a dictionary. So we have, for each ingredient, we have to identify how much you need it and in what kind of unit. Instructions is probably the easiest way. It's just a list of strings or sentences. But then you sometimes also have to do something with serves and timing, because in this recipe it says enough for 2. So you have to kind of think, 2 is people, probably, right? So, and I will talk about this in the later slides. And with time sometimes you won't be able to find just like, a separate sentence. You actually have to figure out how much time you need for prep and cook. So the first problem you have, it's a classic NLP, natural language processing classification problem. And we built a categorization model which is able to identify 4 different types of sentences in each recipe. Ingredient, instruction, serving, and timing sentences. How did we do that? Well, we basically labeled manually hundreds and hundreds. To be honest, I think that you need, for a proper model, you need probably thousands for each label, sentences, and we teach the model to identify these sentences in text. To be honest, it's the simplest step in our pipeline, so it works pretty well. Also, maybe to note that some sentences in the recipe we just drop because some chefs like explaining that they like shopping in at their local supermarket or market, for example, or in Italy the best brand for this passata is this and that. So we kind of, we disregard these sentences. But okay, you have your first model, and you can extract all these sentences, so ingredient sentences, instruction, serving and timing sentences, but it's not enough for structured data, to have a proper table with structured data. So you need the next step, and the next step would be to actually identify how much of each ingredient you need, in what kind of units. We do not do anything with instruction sentences, but I will talk about like humans in the loop and how we curate this data at the final step before publishing. But with serving sentences, timing sentences, we have slightly different approach. So the first one, the ingredient is just ML, so machine learning, and I will talk about this on the next slide. But with serving and timing, we have some sort of combination of some heuristic rules and regular expressions and machine learning as well. So let's talk about ingredient sentences. So obviously, if you look at the first sentence, you might ask, well, it's actually quite easy, right? So if every ingredient sentence would be like this, we would just have a free ride. But then you start looking at other sentences, and suddenly, you start asking yourself, well, what is the amount in the second sentence? Is it 1? What about the unit? Should you actually label large, bunch or just bunch? And what about parsley? Is it just parsley or parsley, finely chopped? And then your amount might be a number, or it might be a word. Then you have ingredient. Is it large lemon or just lemon? And the most maybe difficult part was when we realized that we also have so-called composite units. It's when you have when you need 2, which is probably should be your amount, but the unit itself, it's actually not just a tin, but 400 gram tin. And the model, if you do not show the model enough examples, the model first will be super confused between this sentence and the first one, right? Because it will kind of try to actually figure out some math here. So don't do any math, just keep it simple. So the language we use is so versatile that it wasn't enough just to show the model a bunch of ingredient sentences and teach it. So we needed to annotate a lot of data manually for each of these marginal use cases to train a good enough model. Okay, so how can you do that? I'm pretty sure that many of you know what it means, but NER, named entity recognition technique. So this is the process, but for those of you who are new to this, this is basically a process of information extraction from text based on some predefined categories, or we call them entities, named entities. So in this particular case, you can see that I just used a default pre-trained model by Spacey, and the model was trained to recognize, I think that the default is like 6 or 7 different entities, but it's mainly personal names, organizations, geolocation, etc. But there are no units, ingredient, and amount in this model. So how can you do that? How can you jump from this model to something that you need? So the beauty of this technique is that you can use already pre-trained kind of baseline model, and then you can basically fine-tune it and train a new model with your predefined entities, just showing the model enough of these examples, and the model will learn. So this is exactly what we did. But before we do that, if you remember, when I was talking about all these questions, what should we do with, with units, how should we define ingredients, etc., etc. So basically, if you work on building this training data set, you usually need a number of annotators, but you also have to overlap your annotations, and you have to understand if all these kind of annotators are on the same page. So to do that, you first have to write very, very clear annotation guide. And this is what we did. It's just a screenshot of our annotation guide that we used for building this training data set. And we spent, I don't know, maybe like 5-6 hours overall annotating this as a group and debating, and obviously, every annotator had their own opinion about what we should do, but finally we kind of converged, and we were good to go. But this is very important, to be honest. I will emphasize this again on my last slide. But quite often we just disregard this and really want to speed up the process. Jump on the task, but it will save you time later. So this is how the platform looked like for annotating. Again, we used the paid product by Explosion AI, people who are behind Spacey models. It's called Prodigy. You need a license for this product, but trust me, it's just worth every penny because we use it all the time. And you can see that in this instance, we just have one sentence, and you have 3 different entities, and you can basically change the span. You just highlight with a cursor, what exactly you want to define as an entity, and click accept. Another thing that I want to mention, just from a practical point of view, so what we usually do when we train models like this, we annotate, several hundred, maybe 500 or something like that. Then we train very quickly a baseline model, and we put it in the loop. So basically, and you go through annotating to correcting process. So in this instance, you might imagine that all these in different colors, all these entities were already predicted by your baseline model. So all you need to do is just either to accept if it predicted all the entities, or you can change and correct the span for each entity. It saves you a lot of time, so it speeds up your process just absolutely amazingly, because you can imagine when you have like an empty, like a plain sentence, and you have to read everything, and rather than just basically correcting the model already. And you can get a sense of where you are going, like are you progressing or not, very quickly. So really recommend doing that. Okay, so then let's talk about other sentences. So basically, this approach we used for ingredient sentences, but when we started looking at timing sentences, the problem was that we also had a lot of different verbs that we tried to identify if these verbs mean prep time, active cooking time, or passive cooking time. So in the end, we basically trained another model in the same way as for ingredient sentences. So this model was able to identify time and also identify so-called qualifier. But after that, we had basically a dictionary of all qualifiers that, commonly used qualifiers that we put in different categories. So we basically could go through simmer to, rest time, etc. So that was a combination of ML and some rules. And with serving sentences, I actually want to do the same, but we are not there yet because it kind of works okay. But we didn't do any ML with these sentences, but what we did is some logic to identify people and items. So if it makes 20 cookies, so we say that it's it's 20 items. If it's people, we just say that it's 4 people, etc. So quite straightforward. So in the end, we had 2 layers of machine learning. So first, we obviously identified the category for each sentence. If it's an ingredient sentence, we also applied an NER model for ingredients. And in the same way, we deal with timing sentences. So what we have in the end is our pipeline. We call it structurizer. So basically, you have an article. In this article, you have different recipes. And then we apply the categorization model. We get all the sentences. Then another ML layer, some rules applied to everything. And in the end, we have a very nicely structured JSON file that opens so many different opportunities. And I will talk about this in a moment. But obviously, we do not publish anything automatically, so it's not like you press the button and it appears on the app. We take our users' experience very seriously and also our reputation very seriously. So we have a human in the loop. So basically, what we did, we embedded our pipeline in our CMS. It's content management system. So it's where journalists write their articles, and this is how it looks like. So this is just a screenshot of our CMS. So this is your text. A journalist comes to this CMS, highlights to this article, highlights the text that they want to get a structure. There is a small button there, creates a recipe from text, and on the right side, it will, the table will appear with all fields pre-filled with our pipeline. All you need to do is just quickly check that everything is fine. So at this point, obviously, we worked a lot with UX, etc. It really depends, how you want. What kind of style basically you have in your app, and the style in the app might differ a little bit from the web. That's why sometimes they have to just tweak the exact order, for example, of units, amount, etc. But it's we really wanted this to be minimum effort. What maybe takes time, it's to edit instructions, because indeed, sometimes instructions might be quite more prosy on the web, and you have to be much clearer and shorter on the app. But that's basically it's at this point we are just like hands off. So it's about editorial to do with this data whatever they want. So if we are talking about achievements, all our models, they perform really well. I would say the accuracy of these models around 96, 99%. So that's a very good number. The aim of this project, again, was just trying to reduce the time needed to curate the output. And that's exactly what we did. But also, when you have structured data like this, you can think about so many other opportunities. So you can scale the recipes, for example. Okay, the recipe calls for 2 people. I actually have 4 people coming to to dinner. So how can I do that? And you can do this automatically, basically, if you have everything nicely structured. Then we are talking about conversion of units and sometimes ingredient names between Europe and the States. We have actually a huge audience in the States, and it's growing and growing. So thanks to Trump. So we also kind of want to think how we surface this content to different audiences in different geolocations, but also asking, sometimes people ask about dietary requirements. So, for example, I'm on a keto diet or low carb diet, etc. So all this is actually possible. It's not yet there, but you kind of you get the idea, because when you have everything in your table, you can do so much more, right, than just with text. And the last point, no generative AI involved whatsoever. I'm so proud to say that today, because it's a very classic, although deep learning, but very classic machine learning, and something that you can control, you can tweak at any time, you can retrain your models at any time if you want to. We also are thinking about doing some sort of feedback loop, because we have now a lot of curated data and structured in the same way that we can feed back to the model and make it even more reliable. But you can do with this data and with this model so much more. But let's talk about challenges, because it's all like very rosy picture, but actually it wasn't that easy. So I mentioned that the original models were trained in 2020, so it's basically 5 years ago. And those of you who basically work in this field, you know what it means, because in 5 years ago we didn't have OpenAI and all this stuff. But it's not only that. Spacey models, we had to basically, all our packages were outdated. We had to change everything. When you change one package, you have dependencies. So we struggled a little bit with this, but that was probably the easiest part. Just basically technically doing the right thing. The main challenge came from the difference in definitions of ingredient units in all these kind of entities, and the scope itself. Because when we started working on this project 5 years ago, we actually were thinking about structured data for so-called atoms. So this is a very internal language that we use to name this very small, structured, expandable modules that we can, put online on the app or on the web. So the scope was very, very much simpler than the app. We didn't think about like proper app, actually, a subscription app at that point. But the major problem was that the editorial kind of changed their view in terms of what is the ingredient. Like, is it the pure ingredient, as I mentioned, parsley, or parsley like finely chopped or something like that. So the definitions of all these named entities changed at that point, and we had to go back. So basically, we couldn't use the training data of 5 years ago. We had to produce a lot of new training data. So we had to annotate a lot manually again. But also, we repurposed the old training data, trying to kind of figure out if we can heuristically applying some rules and logically still repurpose this data. But it took us some time. And the alignment between annotators, so something that I showed you before, just really, if you are going to embark on a project like this, please do it properly, because we had a couple of times when as a group, we decided that, okay, we are doing in this way, and then after a couple of weeks, we realized that one person misunderstood or whatever, so we had to ditch all the annotations and start again. So, I mean, it's something that you have to pay attention to. And another thing, that when you build a product like this, obviously you have lots of different departments. It's not only data science, it's data engineering, it's app developers, and every single department has own priorities, and you have to be on the same page with everyone. Project management, quite often we kind of overlook these people, but it's super important to get it right. So it's just a lesson that we learned, and hopefully people who come after us will make some better judgments. And very quickly, how much time I have? Still have time. Okay. So if I have time, I wanted to talk very quickly about next step that we did. So we basically launched the app, which wasn't perfect. We had only 3,000 maybe recipes there. But we wanted to actually get the app before our users and gather feedback and basically, like focus next steps on something that really matters for them. And the first feedback we received that, well, search wasn't great. Well, search on our web is not great. I mean, it's those of you who read The Guardian may complain as well. So at that time, we had a very simple, like string matching, something that didn't work that well. And we decided to work on this as our first priority. And we started looking at different options for semantic search. And for those people who do not know exactly what it means, it basically, the main concept behind semantic search is word embedding. So word embedding works like this, where you have your vocabulary of all the words in English, and you basically assign an ID, you can say, to each word. This ID is a vector. It's like might be a 300-dimensional or 700-dimensional vector, depending on which model you use. So what it makes, it places all the words in your text more or less like in this semantic space, where if you are looking for fish, you will be able to surface like cod, trout, sea bass, and tuna quite closely to this word, and things like crab or prawns, which are seafood but not really fish, will be kind of there but a little bit at a distance, and you can play with this very nicely. But it looks very nice, should work. But we had a lot of troubles. We kind of changed different models, different approaches. But the problem was, I still think that we probably didn't have enough data. But all the models that we tried really struggled to differentiate between cherries, like sweet stuff, and cherry tomatoes, or potatoes and sweet potatoes, like this kind of things. So we went through different iterations, and you can see that the first one, version 0, if we are looking just at top results for the search, we had sometimes very weird stuff going on there. Then we tried another approach, V1, a little bit better, and now this is what we have in our app. So the last model, it's a combination of actually, like proper word embeddings. We used a very simple model from Hugging Face sentence transformer, but we also used another logic, like lexical logic, to surface the right stuff. So this kind of mixture of two approaches gave us the best result. Okay, so obviously, we still want to work on search because there are some stuff that we wanted to try to make it better. But we're also talking now about recommendations because as soon as you have all your recipes as embeddings, basically, you can surface the similar recipes. So, for example, someone is looking for tikka masala, and you can surface other recipes which are, pretty similar to this one. Personalization, it's a little bit, it's much harder, I would say. So I think that we will go with recommendations first. But personalization is on our mind. Dietary requirements, nutritional information, units conversion, difficulty level actually quite straightforward. I think that we can do pretty well with this one, and suggesting collections for different regions, because sometimes where it's hot here, it's actually winter somewhere else. So we wanted to look how we can also differentiate this. And that's it. Thank you so much for listening to me. And if you have any questions. We have some time for questions. Yeah, I don't know. But
Thank you, Anna. Do you think if you were starting this project from scratch today, you would go straight to generative AI, or would you still favor traditional methods?
I knew that this question would come up. Look, still no, to be honest. And so the problem is, many things that we struggled during this project probably would be easier now. But I'm not. We are working with generative AI very closely. We have actually like a dedicated team with 2 data engineers and 2 data scientists working on with generative AI specifically. The reliability is just not there yet. And what I personally feel that when we work with generative AI, we have to put so much effort to kind of to chase every possible mistake that in the end it's just that this works really well. And I mean, yes, of course, we spend some time, but I don't think that we would spend less time with generative AI if you want to do it reliably. So that would be my answer. Yeah.
Thank you.
All right. I was just going to add on to that. There's a disconnect in the context of what you're doing. Somebody has already generated the recipes. They don't need to be regenerated. That's why I would veer away from the generative IA, because well, I know they said it was a tuna casserole, but maybe if we put crab in instead, that wouldn't work. But my question is actually more around the validation process. Did most of your validation be human-driven when they would view the results? Or did you have a pattern of expectation or a criterion that you did to the hypothesis that you were using to generate?
Are you talking about search or machine learning models that we built in?
The building
it's slightly
but
different. Yeah, but it's slightly different. So I can talk about both. So when we were just as a note, all our recipes are actually written by chefs. So, and we are really proud that we work with them. I know that some people now generate, you can generate a lot of recipes, with generative AI, but we actually really proud working with these people, and they also, it's like, we have a very close relationship with them, so we will never do something like that. This is one thing, and this is just from the editorial point of view and from ethical point of view. But in terms of the evaluation process, so for machine learning, all the models that we built as a pipeline, we had the manually curated, data set, and it's just a very classic evaluation process, right? So all the metrics like accuracy, F1 score, we used F1 score. So this is one thing, but in search was very different and very difficult, because with search, we built an app with Streamlit, where we put 2 models usually, so we had a pair of models, and we asked editors, or we did ourselves, some kind of annotate. Well, basically it's just clicking, that looks fine, that looks fine, that's not. So these were the results of the search with different models. So we went through this process, but it is manual. I mean, it's, to be honest, it's if you want to do it properly, the humans are still needed. I mean,
thank you very much for sharing your experience with us. I empathize your pain with spacey models and spacey packages. I've had the same thing, and it's hard to find the models once you go past a year or 2 after they have released it. Yeah. I have a couple of questions. One is, I did see you showed an accuracy score of 96 to 99%. Yeah. And so how are you, so there are 2 questions and one follows the other. How are you determining that actually you're not now entering into an overfitting area? Like, did you have like some sort of checks and balance to say, even though it says 99% accurate, which is nearly 100% accurate, you're not
that's a very good question. To be honest, but in the end, when we started curating, when editors started curating the data, the feedback from them was really, really positive. That meant that we actually, models work okay, because quite often, yes, in this particular case, all these numbers in terms of accuracy, like F1 score, might be very fuzzy because so the spacey, so these kind of models, they look at the span, right? And if sometimes you just miss one word, or you know that is not actually that, for example, finely chopped, model suddenly decided to actually extend the ingredient, but it's not the end of the world. It's still the ingredient, but it will be falsely kind of labeled that it's incorrect. So when we started looking more closely to incorrectly predicted data points, we just realized that, well, actually the model was even performed even better than we thought, just looking at the numbers, because these numbers are very, very conservative because of the span, right? But the main feedback in the end was just from editors who started using the pipeline.
So you're still very confident that the model can still generalize and not
generalize enough,
not
absolutely.
Just, not like tunneled into just those data that you've fed in.
Yeah.
My other question was, if I may, is that did you I know you spoke about the feedback loop where you would go and correct what the model sent back. So, and that's very interesting, and maybe we can catch up later on that. My question here is that in that process, did you have something like, there's a term for it, it's like, you correct it in one place and that's fixed regression. Did you have regressions where even though you had alignment across the whole team, and let's say in theory they all understood the same definition, but you had regression where the model understood it so well that actually small nuances caused correcting in one place, causing a regression in another place, and vice versa, and you just went on in circles.
Yeah,
and sometimes it can be tedious to find. It's like needle in the haystack.
Yeah,
right?
it might be.
Did you have things like
and
that?
we haven't done this yet. So we thought about this, and the problem with this feedback loop, retraining the models automatically. The problem that we had were humans. Because even though the pipeline worked okay and the structured data that they received was correct, they still decided to rewrite it in a different way. And we just suddenly realized that we cannot use this data just straight, like automatically, like in this loop. So we are still a little bit, struggling with this, because I'm not sure. We had lots of conversations like, you shouldn't do that, but especially with composite units, because editors really didn't like these composite units, and sometimes they just rewrote like 800 grams instead of 400. So and this is where you just oops, I just cannot. I cannot use this data because it just will break everything. So yeah, you are absolutely right. It's not that straightforward, and we are not there yet. But structured data opens this possibility. But in a perfect world, I think.
You're in the nuance area, which is probably 0.1%, but you spend most of your time.
But at the same time, we decided that not to put too much effort into this, because it's already working, and we basically ticked our objective boxes, and that's it. But if you want to be perfect,
It's the enemy of the good, right?
Thank you so much. Let's give Anna a final applause. Thank you.